Hi, this is Dr. Nick from the ECG Academy with the next Rhythm Chalk Talk. Chalk Talks assume you know the basics. What I'm trying to do is get you used to reading more difficult tracings. You should also log on to ecgacademy.com to watch a whole series of videos from basic to advanced. Let me help you become an ECG expert. It's easy. And stay tuned for more Chalk Talks every week. Anyway, this is Rhythm Chalk Talk number 3, and I must say it's very challenging. A lot of cardiologists I know wouldn't get this right. But I'm going to help you work your way through it. And one big hint is that this is actually the same patient as Chalk Talk number 2. So that was a case of second-degree type 2 AV block. And one big hint is that Type 1 and Type 2 second-degree AV block almost never occur in the same patient. So, at least not at the same time. So let's get to this. Remember to look at the forest, and the first thing I see is that the QRSs are irregular. Look for a pattern, right? So it turns out that these are regularly irregular with a group of 2, and then a little pause, and then another group of 2. And there's another QRS out here, which, you might think that there might be a group of 2, but you don't know for sure. And I'm trying to get you used to the fact that EKGs are not always perfect. And sometimes you'll just have one little strip to work with, and you'll just have to make the best of it. So once we've decided that there is group beating going on, that there are groups of QRSs, separated by pauses, you have to start to wonder, well, is this a case of AV block? Because conduction disturbances will cause pauses. So let's figure this out. Are there any P waves that we can see? Well, I think it's pretty clear to see that there are P waves that seem to be kind of just hanging out there, not followed by any QRS complex. So you would think that these P waves are non-conducted, and here's another one over here that seems to be non-conducted. So there's a pattern with a non-conducted P wave followed by 2 QRSs, and then another non-conducted P wave, and so on. And so let's review our classification of AV block. Because a lot of people would look at this and say, well, there's P's and there's QRSs and they're all over the place. Could this be third degree, complete heart block? And the answer is no. In order to have third degree AV block present, none of the P waves should be getting through. If none of the P waves get through, then the ventricular rhythm has to be some kind of escape rhythm. If you have AV block, then usually a low junctional focus or an idioventricular focus will arise as an escape rhythm, and the QRS complexes will be regular. These are not regular, so we know that third degree AV block is not present. And it's clearly not first degree because some of the P waves are failing to conduct. So now we have to figure what kind of second degree AV block is it. Well, let's look to see exactly what the P waves are doing, because we've seen these non-conducted ones, but what about some others? If you scan the tracing, you'll actually see that there's what looks like a P wave here in front of this QRS, and there's another one over here. So let's get out our trusty calipers and try to make some sense of this all. Well, first, we'll move the calipers to where we think there are 2 P waves in a row, and I've already adjusted the calipers to the right rate. And so what happens if we move this caliper over to the next beat, and you see that there's a P wave there that's just in front of this QRS complex. And if you measure back from this P wave, start here and measure backwards, you see that it lands on top of this P wave. So the P to P interval does indeed appear to be very regular. And if we figure out what rate it is, we can put our caliper on a heavy line. And let me write to the correct layer. So we'll count off 300, 150, 100, 75, 60. So it's probably about 65 or 68 beats per minute. All right. Let's get rid of these calipers. We don't need them anymore. So you have a sinus rhythm, because the P's appear to be upright. You have a sinus rhythm at 68 beats per minute, and some kind of AV block is going on. Well, let's try to figure it out. Now here's an interesting way of telling which P's conduct and which don't, because it's maybe a little deceptive sometimes. If you look at two of these beats, the beginnings of these groups, and let's just say that this was an escape rhythm. Okay, so let's find the midpoint between these two beats, and that would be somewhere around here. And so if this was an escape beat, an escape rhythm, and there was the P waves, none of the P waves were getting through, then a QRS would have fallen somewhere around here. But instead, what happened is this QRS was moved up. It occurred earlier. So that tells you this QRS had to have been conducted from above. This it makes sense because there is indeed a P wave in front of it. And interestingly, the PR interval here is about 0.2, which is around the same as the PR intervals that we saw in Chalk Talk number 2. Remember, it is the same patient after all. So I think it's safe to say, let me change my color just to, that this PR interval conducts, and then this P wave blocks. And then the question is, well, what happens here? And it does look like there's a P wave, but the PR interval is extremely short. Much shorter than you would expect if this P were to conduct. Remember, PR intervals generally can't get to be that short because the AV node is supposed to delay the signal a certain period of time. So it's unlikely this P wave conducted to this QRS complex. So where did this QRS come from? Well, it's an escape beat. That's exactly what it is. Think of it this way. This patient's AV node is not working, right? So this beat was conducted okay, but when this beat blocked, you have this long interval where there are no heartbeats, and the ventricles start to say to themselves, something, we gotta have to do something. We can't just let this person die. So an area in the conduction system fires as an escape focus because think of it this way: the normal escape rate of the AV junction is about, like I said, 40 beats per minute or so, and this is clearly lower than 40 beats per minute. So that would explain why the P and the QRS occur nearly simultaneously, and that's because this happens to be an escape beat. Some people would look at this and say, oh, well, this must be type 1 second-degree AV block because the PR is short, and then it gets longer, and then it blocks. And someone told me that if the block is less than 2 times the previous R to R, so let me measure this. We'll get our calipers back and say, okay, here's the R to R of this beat, and we'll have to think of it being a little bit longer. And let's measure this pause. And the pause, indeed, yes, look at that. It's less than 2 times the previous R to R. So that must be wanky back. Well, the answer is wrong there because this is one of the exceptions to the rule, because this QRS complex here is, in fact, not conducted. It occurs earlier because the focus in the conduction system fired prematurely and allowed this beat to kind of break the rule, break the winky back rule. So if this is an escape focus, where did it come from? Well, you might think that it's a junctional escape focus, but did you notice that this QRS looked a little bit different from the conducted QRS complex? Yeah, this is the conducted beat, and this beat that follows the long pause, which we already are thinking that is an escape focus, looks different. So it's not a junctional escape. Let me try to explain what's happening here. So you've got your 2 atria, right? And then you've got your ventricles. And if you think of the conduction system as being the AV node, and then your His bundle, and then your bundle branches, the right bundle branch and the left bundle branch. Well, if the escape focus was in the AV node down here someplace, you would expect the QRS to follow the normal conduction pattern and be pretty much the same as the conducted beat. But instead what happens, because this patient has AV block, we've already decided this person has second degree AV block, the AV node must be pretty sick. And even the AV junction is pretty sick and it's not generating the proper beat. But somewhere down here in the Purkinje system, there is a healthy focus that's taking over as the escape. And because the beat goes down one bundle and then has to go back up to the hiss and turn around to go back to the other bundle, it kind of distorts the QRS complex. And that's what's responsible for the change in the morphology of the QRS. All right, so to put it in plain English, this beat is not a junctional escape, but it is a bundle branch escape or a hemifascicular escape focus, and that's what makes it look different from the conducted beat. All right, so that is a pretty advanced concept, and I don't expect you guys to get it right away, but if you listen to this video a few times, and if you watch some of the videos that I posted on ecgacademy.com, I hope you'll understand the physiology. So what we have here is type 2 second degree AV block, since you really only have one PR interval that is conducted. Remember, this is the same patient who had type 2 before. You have a hemifascicular escape beat that makes the PR appear to shorten, but it's not really conducted. And that's really the nutshell of this tracing. It's pretty complicated, but I hope you'll at least take away some important lessons in how to approach this kind of very complicated ECG and how ECG experts will use the physiology to figure out exactly what's going on. So that's Rhythm Chalk Talk number 3. I hope that helps a little bit. Some of these Chalk Talks are going to be very basic, and some of them are going to be very advanced. So you get what you can out of each one. And if you log on to ecgacademy.com and go through all the videos, you'll get used to it, because after a while, it's just a matter of pattern recognition. So thanks for tuning in, and stay tuned for more Rhythm Chalk Talks.